Now look at these terms. Zero vector. A vector with the initial point A and terminal point also A, that means the displacement is 0, is called a zero vector. It terminates where it started. The displacement is nil. Then we know unit vector. Unit vector is a vector of magnitude unity. Example, I cap, j cap, k cap, etc. Then I cap means unit vector along the x-axis, j cap is the unit vector along the y-axis, and k cap is the unit vector along z-axis. By a cap, we mean the unit vector along the vector A, which is equal to vector A divided by modulus of vector A. Any vector can be, see, a unit vector along a normal can be n cap. N cap is equal to vector n divided by modulus vector n. That is regarding unit vector. Now co-initial vectors. Co-initial vectors. See, from the origin O, we can draw a number of vectors. Vector OA, vector OB, vector OC, they are all co-initial vectors. Now, what is meant by collinear vectors? Now, collinear vectors, if we get parallel vectors, we call it collinear vectors. That means a vector can be represented by a scalar multiple of the other. Whether it is in the opposite direction is not a problem. So collinear vectors. Collinear vectors are parallel vectors. Now negative of a vector. Negative of a vector. We shall consider vector AB. Negative of vector AB is equal to vector BA. The terminal point becomes the initial point, and the initial point becomes the terminal point. Now, equal vectors. What is meant by equal vectors? Consider a parallelogram. AB, CD. Length of AB is equal to length of DC, and they are parallel. Therefore, we can write AB is equal to DC. They are equal vectors. Their magnitudes are same and their directions are same. That is the case with vector AD and vector BC. Vector AD is equal to vector BC. Initial points and ending or terminal points, they are different, but the magnitudes are same and the directions are same. Therefore, they are equal vectors. Then vector AB can be put equal to position vector of B minus position vector of A. How is it possible? O, Z, X, Y. Let this point be A, X1, Y1, Z1, and at this point B, X2, Y2, Z2 in the first octant. Now we have to find out how much is vector AB. Here the directed line segment is AB. That is, the vector has initial point A and terminal point B. See, vector OA will be equal to x1 I cap plus y1 j cap plus z1 k cap, and vector OB will be equal to x2 I cap plus y2 j cap plus z2 k cap. By triangle law of addition of vectors, OA plus AB is equal to OB. See, vector OA plus vector AB will be equal to vector OB. This vector can be marked as vector A and this one by vector B. Therefore, vector AB will be equal to OB minus OA. Now, OB is equal to B and OA is equal to A. Therefore, vector AB is equal to position vector of B minus position vector of A. B means OB. Then vector A means OA. Now we have seen vector AB is equal to position vector of B minus position vector of A, and we concluded so using the triangle law of addition of vectors. Right.